Lesson 1, Standard Position. This section will focus on sketching an angle from 0 to 360 degrees in standard position and determining its reference angle. Determining the quadrant in which an angle in standard position terminates. Determining the exact values for sine, cosine, and tangent ratios of a given angle with reference angles of 30, 45, or 60, and solving problems involving trig ratios. Angles in standard position. An angle is said to be in standard position if the initial arm of that angle lays along the positive x-axis, and then the terminal arm, it's rotated clockwise around the terminal arm. So its vertex is at the origin of the coordinate grid. Its initial arm coincides with the positive x-axis. Angles in standard position are always shown on the Cartesian plane. The x and y axis has divided the plane into 4 quadrants. And so we start with between 0 and 90 degrees. These angles are in quadrant 1. Between 90 and 180, angles end in quadrant 2. Angles that are between 180 and 270 degrees land in quadrant 3. And angles that are between 270 and 360 degrees will have their terminal arm in quadrant 4. For each angle in standard position, there's a corresponding acute angle called the reference angle. The reference angle is always positive and always acute. The reference angle is formed by the terminal ray, which is this one, and the nearest ray of the x-axis. So this is the nearest ray of the x-axis, so this angle in here is the reference angle, or theta r, for the angle of 230 degrees. So how do we find that angle? Let's erase a couple of these lines. 230 degrees, the initial arm is along the positive x-axis. It rotates this far, which is 180 degrees, and then it rotates that distance of that reference angle. So to find the reference angle, we can say that it's 230 degrees minus 180 will give me the reference angle. Therefore, my reference angle is 50 degrees. Please note you need to think differently to find reference angles in different quadrants. So if the terminal arm is in quadrant 1, it happens that the reference angle is the same as this original angle. If we're looking for a reference angle here, it's going to be 180 degrees minus our original angle. In this one is 180, and this is my theta r, so this is like our example that we just did. And in quadrant 4, we would probably look at going all the way around, but subtracting what our reference angle is. So let's look at some examples so that makes more sense. So if the reference angle is 20 degrees, find the size of the original angle in each of the 4 quadrants. So let's go back up to the top. It says if my reference angle is 20 degrees. So in this case, the reference angle is in here. So if my reference angle is 20 degrees in this quadrant, then the original angle is also 20 degrees. In this one, if my reference angle is 20 degrees, then this original angle is going to be 180 minus 20, or 160 degrees. If we're in quadrant 3, and my reference angle is 20 degrees, to find the original angle, I would have to go 180 plus 20, and so that original angle would be 200 degrees. In quadrant 4, if I know that my reference angle is 20, we're going to go all the way around, so 360, and then come back the size of that reference angle. So we would end up with 340 degrees as the original angle. So sketch an angle in standard position. State the quadrant in which the terminal arm lies. So if we do our sketch, if we're sketching in standard position, means we have to have the coordinate plane. The original or initial arm lies along the positive x-axis, and then I'm going to rotate in a counterclockwise direction 36 degrees. So I would come up this way 36 degrees. I know that it's less than 90, and so it's somewhere in here. So what quadrant is this? This is ending in quadrant 1. Example B. Again, the initial arm has to be along the positive x-axis. If I'm rotating, I get this far and I get to 90 degrees. This far and I get to 180. I don't want to go all the way to this bottom, so I know that I'm going to end somewhere in here. So this angle is 210 degrees, and it ends in quadrant 3. 315 degrees. Again, that initial arm is on the positive x-axis. So rotating 90 degrees, 180, 270. So I know that that terminal arm is somewhere in here. This angle's terminal arm is in quadrant 4. Determine the reference angle for each of the following angles. Sketch the angle in standard position and label the reference angle theta r. So sketching it in standard position. Again, initial arm on the positive x-axis. We're rotating 90 degrees. We don't want to go all the way to 180, so we know that it's ending in here. So this angle is 130 degrees. The angle in here will be my reference angle. And how do we find our reference angle? Well, in this case, the reference angle will be 180 minus the 130 of our original angle. So our reference angle will be 50 degrees. For the second example, again, 90, 180, 270, so I'm coming a little bit further. So that original angle is 300. My reference angle is this one in here. To find that reference angle, we're going to do 360 minus the 300 from our original angle, so the reference angle will be 60 degrees. Determine the angle in standard position. Determine the measure of all angles in standard position between 0 and 360 degrees that have a reference angle of 35. So we can have a reference angle in 4 different spots. We can have where that reference angle is in quadrant 1. We can have it where the reference angle, I should label that, is in quadrant 2. I can have it where the reference angle is in quadrant 3. Or we can have the situation where our reference angle is in quadrant 4. So let's go back to the first one. If our reference angle is equal to 35 degrees, and we're only going around one time, so we're going only between 0 and 360 degrees, the only angle that can have a reference angle of 35 in quadrant 1 is just 35 degrees. If our reference angle is in quadrant 2, we're now looking at this angle as our original angle. And so we would do 180 minus 35, which is 145 degrees as my original angle. If we're using our reference angle in quadrant 3, means that we're starting again along that positive x-axis and rotating all the way around. So this is going to be 180 plus 35, or 215 degrees. The last situation, again, we're starting from that positive x-axis and rotating all the way around here. If our reference angle is 35, then we're going to find our original by doing 360 minus 35. And so that original angle is 325 degrees.